We are starting chapter 5 today. Chapter 5 is where we're going to talk about rational numbers and equations. So, the first thing we really need to talk about is what in the world is a rational number. So, if you look at your notes, there is this awesome picture down here that really puts a visual as to kind of comparing what rational numbers are compared to integers and whole numbers, which is really the only thing we've talked about so far. So, if you look here, this big blue box is what represents real numbers. Real numbers are the ones that you will most commonly deal with, and even more so, rational numbers, which is what we're going to talk about during this chapter, includes all of the fractions, decimals, whole numbers, integers. As you can see, since they are ingrained in this circle, all integers and all whole numbers are rational numbers. These are the only two that we've really talked about so far, and we see the irrational numbers are in their own little area off to the side, but they are all included in the real numbers. So first, let's kind of put an idea and a definition as to what a rational number is. A rational number is a number that can be written as a quotient of two integers. In a little bit easier terms to understand, a rational number is a number that we can write as a fraction. So that's really the first thing that we want to be able to do. So if you go down on your notes a little bit where it says show the number is rational by writing it as a quotient of two integers. That's how you can say, yeah, that number is a rational number because I can write it as a fraction. So we are going to squeeze 6 examples in that little space down there. A lot of these you already know how to do. We just weren't really sure that's what we were actually doing. So let's look at the number 22. If this number is rational, I should be able to write it as a quotient of two integers, or like I said, I should be able to write it as a fraction. Now, I've asked you before, if I have a whole number, how do I write it as a fraction? Well, that one's easy. You just write it over 1. So if I want to show 22 is rational by writing it as a whole number, I would write it as 22 over 1. Okay, next, let's look at a negative number. What if I want to write negative 15 as a quotient of two integers? With negative numbers, you're going to do it very similar to the positive numbers we just looked at, except you're going to have two answers. First off, the easy one, I can just write negative 15 over 1. What you really need to double check is this negative 15 was a negative number, right? Negative 15. So whenever I write it as a quotient of two integers, it should also be negative. I have a negative number divided by a positive number, and we all know that a negative divided by a positive gives me a negative number. So that's one answer. The other one, I could write this as 15 over negative 1. They mean the exact same thing, and if you notice, I have a positive divided by a negative, which still gives me that negative number I needed. Okay, the next kind of examples, if I have a mixed number, I have 10 and 1/2, and I want to write it as the quotient of two integers. And it's kind of close. I have that 1/2, but that 10's not included in it. So I just want the quotient of two integers. So you may remember how to do this, but just as a little quick reminder, if I want to write a mixed number as an improper fraction, which is what our goal is, because an improper fraction is going to be a quotient of two integers, you're going to start with your denominator, and you're going to multiply it by your whole number. So the first thing I do is take 10 times 2, which gives me 20. And then you're going to continue the circle around, and you're going to add your numerator. So 2 times 10 gives me 20, plus 1 gives me 21. That's the number that goes into your numerator. Okay, well, I want to write it as a quotient of two integers. That's just one integer. So for my denominator, that one's easy. You just carry it on over. The denominator stays the same. So 10 and 1/2. If I want to show it that it is a rational number, I can rewrite it as 21 over 2. Okay, let's look at one similar, except this time I have a negative number. These ones are done almost the exact same way, but the most common mistake I see people making is they're taking 3 times negative 8 plus 1, making it too confusing. If negative 8 and 1/3 is negative, the only way that negative is important is because it tells me that my whole number is going to be negative. So if the mixed number is negative, my improper fraction is going to be negative, then forget about it. So I know I'm going to have a negative improper fraction, then I'm going to kind of forget about the negative sign. Do it the same way. We're going to multiply my denominator by my whole number, so 3 times 8, and then we're going to add my numerator plus 1. 3 times 8 plus 1 gives me 25, and then we're going to carry over my denominator. So a negative 8 1/3, written as the quotient of two integers, is negative 25 over 3. Okay, so far we've looked at writing whole numbers as a quotient of two integers. We've looked at writing mixed numbers as a quotient of two integers. The other types we want to be able to write as a quotient of two integers are decimals. So let's start with 6/10. If I want to show 6/10 is rational by writing it as a quotient of two integers, you're going to write it as a fraction exactly as you would say it using proper place value. So like I said, this is 6/10. So think in your head, what would 6/10 look like as a fraction? Well, you would write 6/10. But we're not done because we're awesome, incredible, amazing students, and we're never going to leave a fraction that's not simplified. So we need to see if they have anything in common. And I do see that 6 and 10 both have a 2 in common. So when we divide a 2 out of the numerator, we get 3. When we divide a 2 out of the denominator, we get 5. So 6/10, written as a quotient of two integers, is 3/5. And last one in this section, if I want to write 5/100ths, and let's tack a negative on there, as a quotient of two integers. Exact same way, and if you remember up here on this example how I said if there's a negative, it just means that your answer is going to be negative, and other than that, it really doesn't matter. So the first thing I like to do is if I see this negative here, I know my answer is going to be negative. So wherever I write my answer, I'm going to go ahead and put a negative down there. That way I don't forget about it. Just like on this last one, how I said 6/10, this one is 5/100ths. So if I want to write 5/100ths as a fraction, it would look like 5/100. And just like before, we always want to double check and make sure it's simplified. And in this case, I can divide out a 5 from both the numerator and the denominator. 5 divided by 5 gives me a 1 in my numerator. 100 divided by 5 gives me a 20 in my denominator. All right, the last thing we want to be able to do today is write a fraction or a mixed number as a decimal. So we're going to do 3 examples down here. Now I know that a lot of this stuff you guys have already done, so I'm really hoping that a lot of it is a review. A lot of these are just going to be some long division, which I know you guys love. Really looking forward to that. So let's look at our first example. If I want to write 5/8 as a decimal, remember, whenever we talk about fractions, it's really just a fancy division problem. That means we take 5 divided by 8. So if we set up our division problem, if I look, 8 will not go into 5, so I need to add a decimal. I need to add a 0. Now I can ask myself, how many times will 8 go into 50? And I know it will go in 6 times. 8 times 6 gives me 48. And then we're going to subtract. 50 minus 48 gives me a 2. I'm going to add a 0, bring it down. 8 will go into 20 2 times. 8 times 2 gives me 16. 20 minus 16 gives me 4. Let's add another 0 and bring it down. Oh, and I see now 8 will go into 40 5 times, and it goes in evenly. So if I want to write 5/8 as a fraction, it would look like 625 thousandths. Okay, let's look at another one. This time, if I have 7/12ths, and I want to write 7/12ths as a decimal, remember that means we're going to take 7 divided by 12. Okay, well 12 won't go into 7, so the first thing I need to do is add a decimal and add a 0. And now I know that 12 will go into 70 5 times. 12 times 5 gives me 60. 70 minus 60 gives me 10. We're going to add a 0, bring it down. I know 12 goes into 108 times. 12 times 8 gives me 96. 100 minus 96 gives me 4. And we've got to go again, add a 0, bring it down. 12 goes into 43 times. 12 times 3 gives me 36. And we're going to subtract. 40 minus 36 gives me 4. Add a 0, bring it down. I see I have 40 again. Okay, so things are starting to look a little fishy because I know that 12 will go into 43 times. And then I get another 36. And then I get another 40. So what's going to happen is what you may remember. This 3 is going to repeat over and over and over and over again. So instead of writing 0.58333333, we can write this as 583 thousandths. And then if that 3 is going to repeat, we put a bar over the 3. And in mathematics, that symbolizes that that 3 repeats over and over and over, and it never ends. Or it never terminates. All right, and last one here. Let's try a negative 4 3/10. Once again, just like all the other ones, if you see that negative, I know that my answer is going to be negative. So write an answer down wherever your answer, or write a negative wherever your answer is going to go, and then forget about it. There's 2 ways you can do this one. I could change this into an improper fraction and then divide it that way. Or if it's negative 4 3/10, my whole number is still going to be 4. So I can write negative 4, and then I can actually forget about the negative and the 4, and I just have to change 3/10 into a decimal. So we're going to take 3 and divide it by 10. Add a decimal and a 0. I know 10 will go into 10 will go into 33 times, and it goes in evenly. So I know that I need to tack on this decimal here. So negative 4 3/10 as a decimal is negative 4 3/10.